Thank you, Renata, for the introduction, and it's a great pleasure that I have the chance to introduce my experience in teaching data science courses here at the South Big Data Hub Education Workforce Group. So today I will be sharing some of my experience when I teach data science courses, which is actually most of the courses I'm teaching at my university. So the three data science courses that I'm currently teaching are foundations of data science, machine learning, and deep learning. And actually, every year I'm teaching the first two courses, for our MSDS program, which is a Master of Science in Data Science program, which actually started a couple of years ago, and it's been immensely successful. My class size these days are way above 100 students. It brings a lot of challenges in teaching, but I think it's students are liking it, and also they're happy with all these new data science materials that they're learning. And in our program, we actually have four fundamental courses, like required courses that I have to take. And the two of them, like machine learning and foundation of data science, are what I actually teach. And so it's kind of like I'm playing a role that I need to prepare the students for the foundation of data science so that they can continue, to the other data science courses without much difficulty. So my topic today will be really basic, not particular to any domain. I know a lot of people are talking about like social science or like bioinformatics or medicine, but here I'm really talking about very fundamental data science and machine learning topics and my experience in teaching these courses. And our program actually has two plans. One plan is regular course-based. Another plan actually student can do, for example, the thesis, master thesis with an advisor. And actually right now I have a student working on a master thesis with me for a computer vision project. And in general, actually our department is actually a very small department right now. We are growing, but we only have like 10 tenure track faculty members. So we are clustered around the three directions. One is like data analytics. Basically, my area is database, data mining, machine learning. So it's mainly, I'm mainly in data analytics. And there's also a few faculty members that are strong in cybersecurity. And we also do high performance computing. I also do a little bit high performance computing because I develop big data systems that are parallel and distributed. And so another important aspect of data science is really the interdisciplinary and the domain specific driven way of doing computer science, right? Basically, we really look at applications and the domain. And so we actually have a strong flavor of promoting the interdisciplinary aspects of the program, where students can also take like a business courses, can also take bio-related courses or medicine-related courses after taking the basic, for example, data science courses, techniques. And as a long story short, my experience with teachers over these years is that I have three things that I would like to share with the audience here. One is that for data science, it's really there's more emphasis on hands-on programming. So really hands-on programming is very important. Initially, when I teach, actually I teach a lot about the theoretical aspects, especially because there's a textbook by, I think, John Hopcroft and the other authors. It's more like a theoretical computer science, right? So the students are liking it, especially some students choosing from math department, but most students have difficulty following. And maybe if you think about the data science, really it's for the workforce development and for the job market, right? So later I switched to hands-on programming, and the feedback is much better. And now all the courses I have a very strong flavor in hands-on projects. Another thing is that we need to give students a very clear big picture of data science, right? Because these days it's we always heard of these words like big data science, AI, right? So it's a little bit confusing, right? And there's a boundary, and important that students have understanding of right? What are these things, and what are specific domain? What are the fundamental skills down there, right? If you look at, for example, CS rankings, they don't have a discipline called data science or big data, right? So how like it's actually a combination of multiple areas, for example, right? So if they have a clear picture, they know where they really like, and they can move to and play a role in the data science world. And finally, what I found important is balancing the teaching of the basics and the frontier, right? Because data science, especially like deep learning, right, these days moving like crazy, AI. And if we teach a lot of frontiers, that will also occupy a lot of time that we teach the basics. So we need to build a solid foundation for the students and let them know the big picture, for example, and then they can move to the directions that they like. So firstly, I will give a few words on the programming side, right? So I have very strong emphasis on programming in my teaching. Actually, if you look at let's say 30 years ago, like when in my undergraduate, right? So my instructor teaching me C++, right? So he always mentioned Pascal, so it's like a Fortran language, and also there's early days as a COBOL language, right? So the filing importing system, the US government is trying to find some programmer, and it's very difficult, right? So these are like old days, these programming languages that are popular. And when I'm doing my undergraduate in computer science, actually C++ is a must as a first language, right? And if you look at maybe 10 years ago, Java is more popular, right? Because it removes all those headache, like a memory leak and the delete yourself, etc., right, for the object. And then these days, Python is absolutely dominating, right? So in statistics, maybe a lot of packages are still necessary, but if you look at data science, people are doing dominantly Python. Right? So what should be the first language that students choose? So my courses actually go with Python, and I think that's the right choice for data science, right? But I don't think it's the right choice for computer science, and these are two different tracks and programs from my perspective. For computer science, if you are building basic things, still need C++, and a lot of Python packages are actually written in C++ using like a PyBind 11 or something, like open the API, right? So, and for software engineering, at least at my days, most of the students start from Java, right? And these days I see a trend moving to Flask, also in Python, right? And there's a Node.js for the backend. Right? So I think the technology moves fast, and people are moving to languages that allow us to broaden the participation of people in computing. But of course, there's a trade-off, right? So I think why Python is the right choice for data science? It's really because I think for data science, it's what I think is called applied computer science, right? It's application driven. And if you look at some people early days talk about data science, it's really computer mathematics combined with a domain, right? You need to work on a particular domain, whether it's social computing, whether it's bioinformatics, or whether it's like a medical imaging, etc. So it's really a particular domain that you apply your computer science and the math skills upon. And it's also a fast track learning. If you look at the regular computer science program, we need to teach all kinds of like operating system, compiler, all these things. Actually, now these days, we teach a lot more about the data science related skills and play down a little bit about the computer science, the very fundamental computer science side, right? So, and another important thing that I find is very important to build like a impression on the students, right? They need to know that data science, they need to learn a lot of tools and learn a lot of models so that they know how to use the tools. Basically, we are not the tool builder if we are in data science, but we need to know a lot of the analytics, statistics, machine learning tools so that we can use them. Right. So these days, one interesting thing I find like in the recent decade is that everything that you find you need in, like, I also do a lot of collaboration with other people in other like different domains, right? So whatever we need, almost you can always find a Python library that's already there with some function that you can call to achieve this goal, right? And these days people are moving crazily like forwarding deep learning, right? Like a lot of machine learning branches have making non-trivial like improvement in performance because of the deep learning thing. And we have TensorFlow from Google and PyTorch from Facebook that people like they are two dominating frameworks, right? And there's also other packages like NLTK for natural language processing. And programming these days are really easy compared with maybe even 10 years ago, right? A decade ago, right? So for example, if you want to build a classifier, right, on your data, after loading your data, you just call like a classifier class to get its object, like in this line. And then you can fit the model, which means using your training data, you train the model, right? Once parameter is set, then you call predict on your new data, right? So you can see that it's really simple. It makes things a lot easier to broaden participation of other students who previously they are really afraid of learning C++, for example, right? So now they can use this all these data science tools to do projects for their domain of interest much easier. And but I would like to indicate, right? So these are just a set of libraries that my research group have been using. I think that's very good, but there are many libraries. It's a flat structure of data science, right? So for example, for natural language processing, NLTK is like a basic tools for processing the natural languages, right? Tokenizer, etc., right? Parsing, and the GenSum is for, I think, topic modeling, right? Hugging Face is really popular these days. They have like I recently checked this transformer models, 70 something of transformer models these days, right? So implementing the library. And CV2 is for OpenCV, right? And if you work on geospatial data, there's a GeoPandas, right? And there's also Volume for visualizing your data on the map. And we also, of course, have the deep learning libraries like PyTorch and TensorFlow. If you do graph mining, graph visualization, networks, and a lot of other relevant libraries are in Python, right? So these are like a lot of tools. If the students want to do anything in those different kind of domains, they can learn these libraries, and then they can really work on the real projects, really. For example, networks, if you do some like social science projects, analyze the social networks, you can use networks. Right? And if you do some geospatial data, you can use like a GeoPandas. And one thing I find interesting is that we can view Python as an advanced shell, right? So actually, a lot of things down there actually implementing like C or C++ for efficiency reasons, which can be tens of times faster, right? So even NumPy operations, they're actually implementing using, because it's array matrix operations, right? It's using like cache conscious algorithms there, right? So if you look at the scikit-learn library, if you do the testing, actually, they always ask you to give the entire test sample with n sample test, right? In all the sample rows, and they give the labels together in one batch, because it's faster than if you give them one data at a time, write a for loop in Python, right? So actually, it's if you have an API, you really need to call them, and you need to get familiarized with all those libraries up there, right? So, and this is another example for decision tree model in scikit-learn, right? It's actually using Python, which allows some compilation instead of totally interpretive execution. So writing everything by the students itself could be even worse, because the performance may hurt, right? Because down there a lot of libraries are actually in C and C++. Right? And so another important thing that we are seeing these days is a Jupyter notebook, right? So originally I think it's just for Python, so it's called IPython notebook. And these days they also do MATLAB and R, all those interactive languages. Right? And so this is really helpful, because you can add nodes, you can change a block of code, and then you can play with it and fix the bug, etc., right? And visualize things, and then you can have the full workflow being able to see, right? So I think it's a very making those data science tools more accessible and more tractable these days. And of course, if you want to do like a really big project, here is an example on the left-hand side, like a transformer models by Hugging Face library. That's 75 so far, right? So just if you really want to do big projects, I don't think a Jupyter notebook will be sufficient, because you need to debug and tracking all those classes into different files. Then maybe an IDE like Visual Studio or PyCharm would be a better choice. And there's actually, if you really want to go deeper, for example, PyTorch, they have the CUDA extension. If you have some backpropagation operation you want to implement more efficiently, so you probably need to learn these extensions and program them. So it's actually, what I would say is it's much easier to enter this area, but if you want to really have some students really want to go into the depths, right? So it's actually, there's a lot of things they need to learn. And another thing that this is of course just my view, right? I want a student to have a clear big picture in data science. And one thing that I want a student to know is that data science is really not all about machine learning, right? So we also have data cleaning at the very beginning, which can be really time consuming, right? And if you want to analyze the result, usually you want to do some like data visualization, right? So, and see how things goes. And also for training machine learning models, we might need annotation. This can be non-trivial if you want to do computer vision and NLP tasks. You need to use some tools, right? So, and also machine learning is not all about deep learning, even though deep learning is like crazily sweeping the world, right? So, and of everywhere in machine learning. And like Kamin He's ResNet is getting 91,000 citations, even though it's published in 2016. And we are seeing even more machine learning papers these days. And for example, bio-related papers in bioarchive. And so confusion by students is like maybe a decade ago, right? So what's really hard is like Hadoop and Spark, also those Cassandra, also did infrastructures, right? So see, my vision to these are data engineering, right? These are not data science. Usually in a company, you will do all these, you store all the streaming data you have, and then when you want to do analytics, you use these ETLs, those extraction tools, you get your data to analyze. And on there, it's data science, right? So, so we are teaching mainly, we do have a course on like big data programming, which is aimed to teach those things down here. And like the student need to know a path they need to learn for like using Python, right? Learning basic Python is not enough because everything these days are numerical computing in machine learning, for example. So for example, scikit-learn, they have array-like, which actually all the training data, test data are actually array-like. You can put it in the NumPy, right? And also, for example, if you look at PyTorch, TensorFlow, they are backpropagation version of the NumPy operations, right? So if they know NumPy functions well, they still will easily learn PyTorch and TensorFlow. If not, it will be difficult for them to understand things. And also, I give students idea like what is classification regression, what is discriminant models, and generative models. Right, discriminant models are more like classification regression. Generative models, you have the probability and you generate things, right, like generating natural language, etc. Right, and there are also different schemes like reinforcement learning, active learning. What are those concepts? In my machine learning teaching, I really want to give them a clear idea. And then if you look at the recent works that in deep learning, actually, a lot of things are just combination of them, right? So for example, you have an object localization. You first want to give a bounding box location, right? X, Y, center point, and then width and height. They are numerical numbers. So it's actually a regression, right? And then whether it's in the box, it's a cat or dog, it's a classification. It's actually a combination of those things. If they have a clear concept on the basic machine learning, it will help them in understanding more complex models, right? If you have a mask, right, so like a mask Gaussian, basically it's a mask where it's a pixel level classification. Whether if you have an object, it's belong to that object in the pixel or not. It's a binary classification on the pixel level, right? It's still classification. And these days we also have more advanced models like anchorless models. So previously we need to give the anchor boxes, right? Now there's no need to do this manual anchor box sliding, right? And there's like a center net, right? People do a heat map thing first, right? This again, more like a binary map, right? So what's the probability that each pixel is a center point of an object on? And so moving to, let's say, deep learning, right? This is a slide from Paper with Code, right? It's crazy if you look at, there's maybe tens of directions, each with thousands of papers here. And it's like a daunting task for students to move forward, right? So, but does that mean they need to learn endlessly? My answer is yes or no, right? So firstly, they need to learn the fundamentals, right? So there's a lot of concepts that are reused by all those works, just tuned to different data types and applications, right? Like attention and like these days, self-attention mechanism for transformer models, right? And like auto-regressive models and all those concepts. These are just two examples, right? So graph neural network, if they know these concepts well, it's actually a combination of those techniques in different domains. Of course, for the domain specific thing, they still need to spend some efforts, right? So like in natural language, the metric could be BPC, right? And it could be BLEU score for machine translation, etc. There's some benchmark like GLUE, like the the Stanford question answering data set, right? So there are some domain specific things they need to spend time, but if they know everything, it's actually machine learning, deep learning down there, classification, regression, those kind of concepts. And finally, what I want to say is they need to like balance the basics and the frontier, right? So a lot of times because we are doing research, we are really happy with our area, we teach a lot about what we are doing research on, right, for a specific project. But because I'm teaching really basic, like a foundation data science, right, I need to prepare all students so that they can move to different directions in data science, right? So I cannot really spend most of the time talking about my research, right? So we need a balance between like teaching the basics and whether we're teaching the frontiers. The frontiers are moving really fast, like crazy these days. And but usually if you look at most of our students, let's say graduate and they find jobs like in a company, some are IT related, some may not be even IT related, maybe banking industry, maybe business, maybe medicine related, right? So we really don't need them to go to the research frontier, but they need to know the basics so that they can use all those tools to work on projects, right? So I put a lot of emphasis on teaching the student basics, big pictures, big ideas, and also how solidify the programming skills with projects. But I do balance the teaching, right? So if there are some students really good and really interesting research, we have some research projects where they can really do an advanced projects and they can push the frontier and delve into a specific topic. For example, we have a final programming project that they can work on more advanced projects than other students. Okay, so as a summary, that's all that I want to share about my teaching. And so we do have some support even for educational grant from National Science Foundation. And I will also acknowledge South Big Data Hub. We get a lot of resources from the Big Data Hub. For example, we had a cloud resources from Azure, I think back in 2017, and also some like training supported by South Big Data Hub to Chapel Hill for like Azure training, and we also actively looking at opportunities in South Big Data Hub. And I do want to thank South Big Data Hub for all those very helpful resources that help build a community in the South for data science. And finally, I would like to thank my employer for providing all those resources that allow me to do all those things that I'm doing. Thank you.